we have been now talking only about the surveys. So next, I would like to talk a bit about instrumented hull ship areas and hull monitoring, because that is in a way also or could be connected with these automatic inspections. And but now let's just look at the hull monitoring itself. So why do we want to have hull monitoring? And one reason is, of course, to have safer and more cost-effective operations of the vessel, so that we know exactly the state of the ship and can better assess the operational risks. And I also brought a small video from an icebreaker. And the reason why I'm showing you this video is why would that be relevant? And also, especially in ice, when we understand the structural loads better, or when we actually know what the structural loads are, we might be able to use the ship in a better way. For instance, now in the Arctic, when we have summer ice, the ice might behave different than first year winter ice. It does not necessarily mean that it's less load, but it might behave differently. And just the information or the guess of the ice thickness might not be enough. So it might actually offer the potential that in certain ice, at certain times of the year, we might be able to go faster with the ship if it's needed, for instance, for research or maybe even for rescue operations. And at other times, we can reduce the speed in order to reduce the fatigue loading. And hull monitoring can, of course, also help us from a financial point of view, because we can use those information to schedule dockings, and also, this is basically the administrative part, the planning of capital expenses. Yeah, and one of the main challenges was always that there was a lack of information to the bridge about the actual load on the hull. When we have been talking about hull monitoring systems, we often talked about so-called traffic lights, green, yellow, and red lights. But from discussions that I had on the bridge, people would actually like to have a bit more details. So such as, for instance, percentages. So just not to break it down in 3 categories, but the percentage just breaks it down in 100 categories, because some of the captains feel the capacity to handle this detailed information. And one other motivation for hull monitoring is that most of the major structural failures that caused significant accidents are related to structural failure. And a survey from Linedong identified that it's time effects of time-dependent deterioration mechanisms, structural overloading. Here on the right-hand side, on the left-hand side, sorry, you see the MOL comfort that was breaking into errors in design, utilization of low-quality materials, especially this utilization of low-quality materials. That does not sound to be very likely, because usually also that steel and the materials, they must be approved by the classification societies. However, when I was reading the insurance report from the MOAD accident, there it was mentioned that there have been steel plates used that it was just mentioned that this new material might have inferior quality. It was not very much specified what it actually meant, but nevertheless, this can happen, and also within an approved process, errors can occur. And then inferior alignments or welding, coating breakdown, and then, of course, the classic vibrations and is induced by external loads. Challenges in hull monitoring is that the vessel health, when we usually want to determine, is examined as a technical expertise using assumed sea conditions, maybe from buoy or weather data, and also the IAS data of the ship. I have to say that in cooperation with DNV, we already tried to analyze these ones within a master thesis, and the results differed quite a lot from the initially made design assumptions. So that it will remain a bit inconclusive whether there was a mistake or whether this was actually true and the difference was so tremendous. But there's still some ground to be covered. And then something that we often miss is the lack of sensors and instrumentation. And also, when it comes to the instrumentation, you see here the image of a ballast water tank. Some of the vessel details, they are hard to reach, so you are actually not able to install sensors there. And the second point is that when you install sensors, or at least sensors such as strain sensors, they usually require an external voltage supply. So that also means you need to have a penetration through the walls at a certain location, which is possible to do. But I have been instrumenting vessels myself, and the amount of cables that you have to pull out of some of the compartments, that is really a lot. So this is actually also one of the problems that you will face when you want to instrument all areas of a vessel. And the second thing is, of course, also the deterioration of sensors, especially if you have them in a such high corrosive environment as the ballast water tank. You can, of course, cover them, but actually you would have to recheck them in regular intervals, which is probably not feasible. And then again, the data of many systems is only streamed to the bridge. That has mainly to do with the fact that the data storage is otherwise a problem, and that then again also limits the ability of the operators to make informed decisions. I mean, one example that I can give from my own experience is that some of the engine data, they are streamed to the bridge with a relatively high frequency, but then again, for the sake of saving, they're saved in 15-minute intervals, and 15 minutes, especially if you're interested in the variation of engine load, that is basically nothing, so you cannot really use them. But on the other hand, if you would save them with a high frequency, not only those data, but many other data as well, that would increase the data storage space that you need quite significantly. Yeah, and then a few words about the approaches. There are different approaches on how to instrument a structure. There's a Norwegian company called Light Structures. They have something what they call a sparse system monitoring, where they apply up to 6 sensors on the longitudinals of the structure, so very few sensors. This might be sufficient to capture maybe some of the modes, if you think about vibrations and certain excitations. But if you want to detect slamming events and look a bit more into fatigue problems, then you need to have more sensors, and you also need to have those sensors in locations that are spread all over the ship. So, and then of course the question is, so what is sufficient? How many sensors do we need? What is economic? Because on the one hand, you might be able to install a lot of sensors on a vessel, but you need to store the data. You need to pay money for the installation, and yeah, there's maybe also a certain limit in benefit, because at a certain number of sensors, you might actually not be able to obtain more information. And this is also a question that is still to be addressed. And for the monitoring, there are also class references, and actually all big classification societies have been addressing that. So, for instance, DNV actually also mentioned a number So they have around 100 vessels that have this HAMON, this hull monitoring class notation, which can also be used in providing routing assistance and so on. And just for the sake of completeness, here are some of the requirements that this hull monitoring notation includes. We have here global structural response of the hull, local structural response, ice response is explicitly mentioned, structural integrity management, environmental monitoring, noise, vibration, propulsion system, and so on. And the measured parameters may also include sea keef motions, vibrations, and operational data, and wave characteristics. And this is actually something that, if you look at the entire list, that is a lot of instrumentation that you need on a ship. And I have so far not really seen a ship that has all these instrumentations. We are also planning currently a research project, but it would be very nice to have, for instance, wave radars to get the characteristics of the sea wave, but not even that is available because it's usually not needed. So there is still, if you think globally about the instrumentation of ships, I think there's still overall still a lot that needs to be done. And still much of the instrumentation is maybe more interesting for us for monitoring and maybe for us as researchers, but for daily operations could be that it's not as interesting.